Hello everyone. I'm going to start chapter 7 by giving a really good example. And this is an important chapter, and I believe chapter 7 is the most important chapter in the whole book. So understanding chapter 7 will help you understand uh, any concept after chapter 7, because chapter 7 is about sampling distributions. If you remember what we did in the past, we used to show some distribution. We used to graph, like for example, we have a set of data. Suppose we have this set of data and we would like to graph it. You can just go and graph that one. Not that way, sorry. Let's go to pivot table. And okay, to graph this, we used to find the count and we used to find the distribution, right? So this is the distribution, for example, of the number of mutual fund accounts. Suppose that this is the population. This is a population, okay? And we have that distribution for the population. We have number 0, 1, 2, 3, 4, 5, 6, and the frequency for each. How many zeros do we have? How many ones do we have? How many twos do we have? And so on. So this is the distribution of the X value, which is number of the mutual fund accounts. So this is just a quick example because I have to go to the other one. So this is the distribution for the population. But the problem that we cannot access the real population. So if we can't access the real population, so there is no need for us to do sampling. There is no need for us to do more analysis because we can get the mean or the average of the population. We can get any other parameters. So the idea is, because it's hard to access any population, so that's why we are doing sampling. But the problem that one sample is not enough. Taking one sample is not going to be enough. And for example, we have some smart TV prices. Suppose that this is my population. And let's find the mean of this, the average of the prices. So the mean is average, let's say. So the average price of these brands is 669. So this is the mu. This is a mu, right? Mu. This is a mu, which is the mean of this population. Suppose again, this is my population. If someone is willing to take a sample, suppose you're willing to take a sample. And let's create this function to take a random sample of 5. So I'm going to have, let me here, sample size 5. So let me take index returning the retrieve my data, sort by B2, B11, rand array, B2 up to B11. Let me have the rows, and sequence So we took a random sample. The random sample, if you look at the function rand array, basically creates the array of random numbers. Sort by basically sorting these numbers that it's taken from the rand array, and the index give us or retrieve or obtain the numbers that we already ask the rand array and sort by to get to us. So the index retrieving the data to us, and how many data we need, it's sequence. The sequence function tells us, because we were looking for 5 values. So index retrieving 5 values. Okay. So we got one sample. So if I would like to find the average of this is a sample. Every time I click, by the way, we get a new random numbers generated. That's okay. This is good for us, by the way. If I find the average of this, let me write dollars here. So this is my average of this sample. So the sample is 635. So let me find the error. What is the error? The error is actually, okay, this average is basically the average of the sample. Let's call it sample average, right? Or the average of the sample. If you remember, we call it X bar, okay? What is the error? The error is the difference between the sample mean and the population mean, right? So it's going to be X bar minus mu, right? Which is X bar. Where is X bar? This one is X bar minus mu. Right? Which is 50 dollar in this case, the difference between x bar and the mu. This is the error, right? So this is the sampling error. We call it. Let's give it a name. Sampling error. So the sample, there is an error. If you take other sample, let's take another sample, sample 2, sample 3. Let's take let's say 10 samples, right? Every time you take a sample, so let me do something here. I'm going to lock these cells by, in Mac I use function F4. Function because I want to see that, or F4 in any Windows or something. Why I did this? Because I would like to lock these values, so when I drag, I'm going to create free samples. Hey, so we got these samples. All of them are also, I don't know why they create so many. Okay, here we go. So we have now different samples, and we can, oh, this is the average, sorry. Yeah, it's the average. This is the average. Let me just, okay. If you look at the sample averages, we have different averages because we have different samples, right? Okay, and if you take more samples, if you take so many samples, you can actually keep calculating this minus this, which is the, I'm going to lock the population, and I'm going to keep subtracting to get the error. So you get different errors. So every time you take a sample, you get different sampling error. The difference between the average of the population and the average of the sample is always different, right? And sometimes it's positive, sometimes it's negative, and it depends on the sampling error. I mean, the sampling error sometimes depends on the sampling that we selected. If we select, for example, if we selected this kind of sample, the error is 10. Sometimes the error is negative. Sometimes the error is positive. Sometimes it's big. Sometimes it's small, right? So for different x bar, we have a different sampling error. So this is a problem, having different samples. So when you have different sampling error, that means you may have different interpretation for the population, right? And actually, sometimes if you take, by chance, if you take the biggest fifth or 5 numbers as a sample, the biggest 5 numbers. So you can have the biggest 5 numbers. If you take the biggest 5 numbers and you calculated the difference is going to be the maximum, right? Or if you take the lowest numbers, the smallest number, maybe it's going to be the maximum. I mean, we will have a maximum or let's say we will have a lower limit and upper limit for the difference at the end of the day. It depends on the sample. If you take the smallest numbers, and if you take the largest numbers. If you take the smallest, let me just sort these from smallest to the largest. These are sorted. If I pick these 1, 2, 3, 4, 5, let me take these as a sample, my last sample, okay? No, not the last sample, the one that, sample 11. Let me find the average. Oops, yeah, this should not be this. This is the average. This is the difference. Look at the difference. Let me take the biggest 5. Sample 11, 12. And I would like to find this. And I would like to find the difference. Look at these now. The average of these guys, all of them. Oops, the average of these. Look at these 2 numbers. And compare these 2 numbers with others. This is the average of the population, right? We took random samples, 10 random samples, and we found that the sampling error is 50, negative 24, 6, 24, 24, negative 20, negative 35, 6, 10, 10. But when I chose a sample that contains the largest numbers, the sampling error was the most, or the highest. This is the highest. And when I chose sample of the lowest 5 numbers, we got smallest difference, smallest sampling error, which is negative 8. If you look at other numbers, this is 0. Again, every click or every something, the numbers keep changing. This is part of the functionality. I can stop this, but I don't want. I like see them like changing all of them, except the last 2, because these last 2, they are just numbers. They are not functions. So what we understand from this, so the sampling error has limits every time. So the sampling error will have a lower and upper limit, right? We have extreme numbers. These are extreme numbers, right? Sometimes you have extreme sampling error. And it's greater, basically, when smaller sample size are used. If you use a smaller sample, we will have extreme sampling error. If you try to pick bigger sample size, you'll see the difference. That if you choose bigger sample, this is a small example. This is just example using a few numbers, actually. If you use other example and you have like 1,000, and every time you take a sample, size, I mean, if the sample size is small and you try to pick bigger sample size, you will have smaller, technically, not every time, but most of the time, the sampling error is going to be smaller. The sampling error is going to be smaller. The idea is, so this is the first idea I would like to talk. The second idea, I will discuss it in the second video. So in this idea, we discussed something we call the sampling error. The sampling error is the difference between the sample mean and the population mean, and we've seen that it's not fixed, it's not constant, but we realize that we have limits for the error. We have upper limit and lower limit.